Hello friends, in the unit we have discussed vibration spectra, vibration rotation spectra. In the previous unit we have studied rotational spectra, then Mode's plot, Oppenheimer approximation and so on. Now it's time to study how these spectrum can be used for structural determination. Today will give you a brief idea about infrared spectroscopy. In this video, we will learn about infrared spectroscopy, basic instrumentation, basic principle, then how functional material can be studied, functions, then instrumentations, how the output cut can be analyzed, and finally FTI and Raman spectra. IR spectroscopy, which is a short of infrared spectroscopy, deals with infrared region of electromagnetic spectrum, that is light having a longer wavelength and a lower frequency than visible light. Infrared spectroscopy generally refers to analysis of interaction of molecules with infrared light. In this, we strike infrared light and we study the behavior of your molecules with this. We study transmission or absorption. The infrared spectroscopy concept can generally be analyzed in three ways: by measuring reflection, by emission, or by absorption. The major use of infrared spectroscopy is to determine functional group of molecules relevant to both organic and inorganic chemistry. Here, I want to mention, whenever you want to characterize the materials, either you prepared in the lab or you search somewhere, then for chemical properties, this is one of the strongest way to check. For other ways, we use structural determination, morphological determination, or optical studies. But for molecular behavior or for idea of functional group, this is the strongest technique to check. That is why for organic and inorganic chemistry, it is a very strong method. Now, the first question is, what is IR spectroscopy? An IR spectrum is essentially a graph plotted between infrared light absorbed on and on the y-axis against frequency or wavelength on the x-axis. In the next slide, I will show how different regions can be classified on this spectrum. This spectroscopy detects frequency of infrared light that are absorbed by the molecules. Molecules tend to absorb these specific frequencies of light since they correspond to frequency of vibrations of bond in the molecule. What molecule will absorb is the characteristics of the molecule, and we utilize this property to check what vibrations are present, which decides which type of bonds are present. idea of wavelength is shown. The infrared have comparatively longer wavelength. Longer wavelength means shorter energy. Infrared is the right side of the red, invisible. Similarly, as ultraviolet is also invisible, but two have different property. They have different in energies. Ultraviolet have very high energy, whereas infrared very low. The energy required to excite the bond belonging to a molecule and to make them vibrate with more amplitude occurs in the infrared region. A bond will not only interact with the infrared radiations but also give some specific output, characteristic output. The bond is intact only when it is polar. I have already discussed these things, these properties, while discussing the theory. The presence of separate areas of partial positive and negative charge in a molecule allows the electric field component of electromagnetic wave to excite the vibration energy of the molecule. The change in the vibrational energy leads to another corresponding change in the diatomic molecule of diatomic moment of the given molecule. The intensity of the absorption depends on polarity of the bond. Symmetrical non-polar bonds are NN, OO, for others are H2 that do not absorb radiations as they cannot interact with electric field. Here, polarity plays very important role. HCl is a polar molecule, H2O is a polar molecule. So, this concept is very useful here whenever we are discussing with vibrational energies. We should all keep in mind when we want to discuss vibration energies, when we want to analyze structural determination of molecules, this should be considered properly. The main attraction of this spectroscopic is we must know the region of infrared spectrum. Most of the bands that indicate what function group is present are found in 4000 to 1300 centimeter inverse. There is a list of functional groups and everything is known where the function group may be present. When we get the output, when we get the curve, using the absorption peaks, we can check the presence of various functional group. Their bands can be identified and used to determine the functional group of the unknown compound. Suppose nitrogen, hydrogen is present, then the next question will be what is the bond between N and H, whether it is a single bond, double bond, triple bond. If they have single bond, double bond and triple bond may give different peaks. So this can be checked, this can be verified by here. Similarly, this can be checked between CC bond, CH bond and so on. The region from 1300 to 4000 is called functional group region, where all functional group present. The region from 1300 to 400 centimeter inwards is called fingerprint region. Bands that are unique to each molecules are similar to fingerprints found in the fingerprint region, 1300 to 400. These bands are only used to compare the spectra of one compound to another compound. Samples in infrared spectroscopy. The samples used in IR spectroscopy can be either solid or liquid or gas. Solid sample can be prepared by crushing the sample in a mulling agent which has oily texture. A thin layer of the mull can now be applied on a salt plate to be measured. Here I want to mention that sample preparation is very critical here, very tricky. Results are based on sample preparation, how good you are to prepare samples, how passionately you can prepare samples. If you have samples, then you have to crush well, and you have to mix well, and you have to apply on salt plate very well. Then you will get good results. Liquid samples are generally kept between two salt plates measured since the plates are transparent to IR light. Salt plates can be made up of sodium chloride, calcium chloride, or even potassium bromide. Most of the time we use KBr, potassium bromide. Since the concentration of gaseous samples can be in parts per million, the sample cell must have a relatively long path length. Light must travel for a relatively long distance in the sample cell. The sample of multiple physical states can be used in infrared spectroscopy. Principle of infrared spectroscopy. The infrared spectroscopy theory utilizes the concept that molecules tend to absorb specific frequency of light that are characteristics of the corresponding structure. This is the principle, basic principle. Molecule will absorb only those frequencies which is useful for vibrations or rotations. That is why they have used the word characteristics. The energies are reliant on the shape of molecule surface, the associated vibronic coupling and mass corresponding to atoms. For example, the molecule can absorb the energy contained in incident light and the result is a faster rotation or more pronounced vibrations. This depends on molecule to molecule. The further details about how to do the sample in FTIR and Raman spectra will be discussed in the second part of this lecture. Thank you.